Let's take a closer look at some polynomial functions. Let's take a look at our first problem here. We got f of x is equal to x squared minus 2x plus 4. And we want to find f of negative 3. Well, we've seen evaluating functions before, so there's nothing really new here. It's just showing how it's applied to polynomials. Well, same idea. To evaluate a polynomial function, we go through and replace all of our x's with parentheses. Everything else remains exactly the same. So we got parentheses squared minus 2 times a set of parentheses plus 4. Now whatever is inside the parentheses right here is automatically what you're going to put inside these parentheses. So I'll put a negative 3 here and negative 3 here. Well, negative 3 squared gives us 9. Negative 2 times negative 3 is 6 plus 4. 6 plus 4 is 10 plus 9 is 19. So 19 is our answer. Now the second one we want to find is f of 2. And again, same idea. We go back to our original function where our x was, we put in parentheses. So I got parentheses squared minus 2 times parentheses plus 4. And whatever's inside the parentheses right here is automatically we'll put in here and here. So put a 2 there and 2 there. Well, 2 squared is 4 minus 2 times 2 is 4 plus 4. 4 minus 4 drops away, so then our answer is just 4. Let's take a look at another one of those. We got f of x is equal to negative 5x squared minus x plus 1. And we want to find f of negative 3 and f of 2. So f of negative 3, again we're going to go through and replace our x's with parentheses. Everything else remains exactly the same. So the negative 5 remains there, the squared, the minus, and the plus 1. All I did is replace the x's with parentheses. Now whatever's inside the parentheses over here is automatically what we're going to put in here and here. So I'll put negative 3 here and negative 3 here. And then we want to simplify that. Well, negative 3 squared gives us a positive 9. Negative negative gives us a positive 3 plus 1. Negative 5, negative 9 is negative 45 plus 3 plus 1 is 4, which ends up giving us negative 41. Now f of 2. Again, we'll go back to our original function. Everywhere we have an x, we'll put in parentheses. So I got negative 5 times parentheses squared minus parentheses plus 1. And again, whatever's inside the parentheses right here is automatically we'll put in here and here. So put a 2 there and 2 there. And we want to simplify. 2 squared is 4. And that's just a minus 2 plus 1. Negative 5, negative 4 is negative 20. Negative 2 plus 1 is negative 1, which then gives us negative 21. And that's our answer. Now the next one combines together some notation with what we have already done before, because we added and subtracted polynomials. We got f of x is equal to x squared minus 7x plus 3, and g of x is equal to 3x squared minus x plus 5. And we want to find f plus g and f minus g. Well, when you're adding polynomials, you just put each one of those in with parentheses around them. So I got x squared minus 7x plus 3 with parentheses around them, plus, and then we put parentheses around 3x squared minus x plus 5. Now when adding these together, these parentheses don't actually do anything, so we combine together like terms. X squared plus 3x squared is 4x squared. Negative 7x and negative 1x gives us negative 8x. 3 plus 5 gives us 8. So that'd be our answer. Now f minus g. Same thing. We're going to put parentheses around each polynomial and put a minus between them. So we got x squared minus 7x plus 3 minus, and then parentheses around it, 3x squared minus x plus 5. This one, the parentheses actually do something. The first set of parentheses don't, so I can just drop them. So I got x squared minus 7x plus 3. Remember, if you have a minus in front of your parentheses, that flips the sign of everything inside. So it doesn't flip the sign of the 3x squared, the negative x, and the plus 5. So I got minus 3x squared plus x minus 5. Flip the sign of everything. And now I'm going to combine together like terms. X squared minus 3x squared is negative 2x squared. Negative 7x plus x gives us negative 6x. And 3 minus 5 gives us negative 2. And that'd be our answer. Let's take a look at this one. This takes that a step further. So we got f of x equals x squared plus 11x minus 1, and g of x is equal to 3x minus 5. And the first thing we want to find in part A is we want to find f plus g and negative 3. So f plus g of negative 3. What this says is it says first find f plus g and then plug negative 3 in for the x. So let's do that first. Let's find f plus g. And if you remember from the previous problem, again we put parentheses around each polynomial. So we got x squared plus 11x minus 1 plus, and then parentheses around the 3x minus 5. In this case, the parentheses aren't doing anything, so I can combine together like terms. X squared, 11x plus 3x is 14x. Negative 1, negative 5 gives us negative 6. Okay. So then, after we found f plus g, we want to plug negative 3 in for x. So we got negative 3 squared plus 14 times negative 3 minus 6. Negative 3 squared is 9 minus minus 42 minus 6, which gives us getting kind of late, my brain's shutting down basic math, negative 39. Double check that. Negative 48, yeah, negative 39. And that'd be our answer to part A. Now for B, it says we want to find f minus g of 2. Again, what this notation says is it says first find f minus g, then plug 2 in for the x. So f minus g, I got x squared plus 11x minus 1 minus 3x minus 5. Now notice I put parentheses around each polynomial, put a minus between them. Now that first set of parentheses doesn't do anything, so I can drop it. So I got x squared plus 11x minus 1. And remember, a negative out in front of your parentheses flips the sign of everything inside. So that's going to flip the sign of the 3x and of the negative 5. So we got minus 3x plus 5. So we got x squared. 11x minus 3x gives us 8x. Negative 1 plus 5 gives us 4. Okay, now that we've found that, we want to plug 2 in for the x. So I'm going to have 2 squared plus 8 times 2 plus 4. 2 squared is 4. 8 times 2 is 16 plus 4, which gives us 24. And those would be our answers for that particular problem. We'll go ahead and save this page. And Let's see what this page should be called. Here it is. And oops. Okay. Let's look at the next problem. Now this gets into composition of functions, and we'll talk more about this later on. So I won't go into a whole lot of detail here. I'll just go into the mechanics of how to find it, not exactly what it means. So we got f of x is equal to x squared minus 7x plus 2, and g of x is equal to x minus 3. First thing we want to find is, and you can drop part of it, we want to find the composition of f and g. This does not mean f times g. This is composition. And we automatically rewrite it this way. We want to rewrite it as f of g. Now how I remembered it, way back when I took college algebra, is f was first here, so f is first here. G is second here, so g is what goes inside your parentheses. Now this is just evaluating a function. So we're going to take our f of x, and everywhere we have an x, we'll put in parentheses. So we've got parentheses squared minus 7 times parentheses plus 2. Now whatever's in, this is always how you evaluate a function. Whatever's inside the parentheses right here is automatically what you put in right here and right here. So we'll put g in there, and we'll put g in there. But g is equal to x minus 3, so this is going to become x minus 3 squared minus 7 times x minus 3 plus 2. So we'll replace the g with x minus 3. And now we want to do a little bit of simplifying. X minus 3 squared, that's x minus 3 times x minus 3. We use the distributive property here. Negative 7 times x is negative 7x. Negative 7 times negative 3 is a positive 21 plus 2. FOIL this, multiply everything together. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is 9. Minus 7x plus 23. Combine together like terms. Negative 3x is negative 6x. And negative 7x gives us negative 13x. And 9 plus 23 gives us 32? Yeah, 32. So that'd be our answer in part A. Okay, part B. We want to find composition of G and F. Well, again, G is first here, so G is first here. F is second here, so F is what goes inside your parentheses. Now again, this is just evaluating a function, so we're going to take our G of x, which is x minus 3, and wherever we have an x, we'll put in our parentheses. Everything else remains exactly the same. And again, evaluating a function is always the same. Whatever's inside the parentheses right here is automatically what goes in right here. So we're going to put f in there. But f is equal to x squared minus 7x plus 2. So this becomes x squared minus 7x plus 2 minus 3. So we replace the f with what it's equal to. And now we'll simplify. So we got x squared minus 7x. 2 minus 3 gives us a negative 1. And that's our answer to part B. Now C. Let's take a look at this notation and see what the world is saying. Now this does not mean take the composition of f and g times 2. What this says is it says first find the composition of f and g, which we actually have found over here in part A. So we already found that. It then says to plug 2 in for the x. So we're going to have 2 squared minus 13 times 2 plus 32. Again, I'm going through and putting 2 in everywhere I have an x. So we're going to have 2 squared, which is 4, minus 13 times 2 is 26, plus 32, which gives us negative 22 plus 32, which gives us 10, assuming I've done my basic math correct. Okay, let's look at another composition. In this one, we got f of x is equal to 9x plus 3, and g of x is equal to 4x minus 8. And we want to find the same 3 items. So first thing we want to find is composition of f and g. Which again, f is first here, so f is first here. G is second, so g is what goes inside your parentheses. Now this is just evaluating a function, so we want to take our f of x, and wherever we have an x, we'll put in parentheses. Everything else remains the same. And again, evaluating functions always the same. Whatever's inside parentheses right here is always what you put in right here. So put g in there. But g is equal to 4x minus 8. So this becomes 9 times 4x minus 8 plus 3. Well, distributive property, 9 times 4 is 36. We got 36x minus 9 times 8 is 72 plus 3, which gives us 36x minus 69? Yeah, minus 69. So that'd be our answer to part A. Now for B, we want to find a composition of g and f, which is g of f. So again, we're going to go to our g of x, and everywhere we have an x, we'll put in parentheses. So I got 4 times parentheses minus 8. This is again evaluating the functions. Whatever's right here in this parentheses is automatically what goes in these parentheses. So put f there. But f is equal to 9x plus 3. So that actually becomes 4 times 9x plus 3 minus 8. 4 times 9 gives us 36x. 4 times 3 is 12 minus 8, which gives us 36x. 12 minus 8 gives us 4. Okay, C. We got this notation, and again, just to refresh your memory what that means. It means first find a composition of f and g, which we found right here. So it's kind of a continuation of part A in that regard. This says then plug 2 in for the x. So we're going to have 36 times 2 minus 69. So again, I put 2 in for the x. That gives us 72 minus 69 and gives us 3, assuming I subtracted correctly. And that's composition of functions. And that's actually the last problem in that section.